All right, thank you very much for coming, everyone. My name is Alex Dunlap. I'm the general manager for Amazon CloudFront. This is what a little bit different format than some of the other sessions. What we're doing here is we call it internally lightning talks. And the idea is let's get some of the engineers who have built CloudFront up on stage, give you some very practical, tangible things that you can do, bring back home and use in your applications and your workflow to make CloudFront perform better, make your websites more available, improve your cacheability. So there was really an emphasis here in this talk on practical, tangible things that you can take away. So for that, again, I'm Alex. We've got Colleen, Jared, and Matthew. So these are all members of the CloudFront team. We're each going to spend about 10 minutes or so going through one topic, kind of pass to the next one about your CloudFront. So specifically, what are the 4 topics we're going to cover today? The first topic we're going to cover is best practice for setting up your origin. CloudFront acts as a cache. The servers or the things behind that cache is what we call your origin. So we're going to walk through some best practices for setting up your origin. Second, Jared is going to go into getting better visibility into your distribution. Where's your traffic going? Who's downloading it? What are they doing with it? What are they watching? Third, Matthew is going to go through how to improve your cacheability. We are a cache with CloudFront. At least for the static assets, we will cache static assets. And there are things that you can do as a developer that will lead to either better or worse caching. Let's understand what those things are and how you can improve your cacheability. And fourth, come back to me at the end. I'll give you a little bit of overview about various types of testing you can do. I'm reading off the slides, not there. There we go. Fourth, it's going to come back to me. We're going to go through and look at various ways you can test your configuration. How do you know that what you've set up is going to work for your end users? So with that, let's start with Colleen to talk about best practices for setting up your origin.
Great. Thank you, Alex. I think first best practice, make sure we're projecting correctly, which it looks like we are. So thank you. So we'll go ahead and get started. So today I wanted to focus specifically on some items that you can follow to improve your availability, get better performance, and make it easier to debug your application as well as debugging any trouble you may have when running CloudFront. So the 5 items I picked out specifically for this talk are utilizing Route 53 health checking and DNS failover for your origin, configuring multiple origins, securing your origin, either if you're using an Amazon S3 origin or a custom origin such as an Elastic Load Balancer, logging request IDs, and these are the request IDs that CloudFront sends, or generating your own request IDs to make it easier to find specific requests from your customers. The 5th item I wanted to speak about is setting origin response headers, and these are HTTP-specific response headers. So, as you may know, Amazon Route 53 health checking and DNS failover is a service we currently offer that allows you to health check any HTTP endpoint on the internet, and based on the health of that endpoint, you can fail over to another endpoint, or you can be alerted if that health check is unhealthy. And you can use that information to make routing decisions at the DNS level. And so in this example, we have a deployment with an Elastic Load Balancer in our US East 1 region. And you can see we have 4 edge locations all doing their origin fetches from US East 1. And so what I can do is I can set up a latency-based routing configuration within Route 53 that routes CloudFront to the least latent AWS region. So here you can see my edge locations in Europe and India are being routed to EUS 1, and my edge locations in Brazil and the United States are being routed to US East 1. And that just happens seamlessly. You never have to worry about updating any latency data. That's all done for you. So let's say someone accidentally terminates all their instances behind our load balancer in one of the regions. So what happens behind the scenes is the health checks will start to fail, that endpoint will stop being returned to DNS, and then CloudFront will start doing your origin fetches from the next available endpoint. And we'll be demoing that as well, where I'll accidentally terminate my instances and see what happens. And here's a sample configuration that you can take a look at. So I have a origin.example.com configured where I have latency-based routing between US East 1, again, and EU West 1. And I am checking the evaluate target health on my ELB, so I get the benefits of getting the health checks that are already built into my ELB, and ROPD3 can make decisions off of that as well. And you can see all the available AWS regions for my latency-based routing. Great. So now the second best practice I wanted to talk about, maybe I'll stand right here, okay, is configuring multiple origins. So here we have a whole website delivery, for example.com, and you can see what I'm doing is I'm configuring some CloudFront cache behaviors that sends assets or maybe my static error pages to S3 and my dynamic content to my elastic load balancer, which then I'm low latency-based routing between AWS regions. So why would you want to do this? So this allows you to decouple your assets, such as JavaScript, CSS, images, from your application and let your application focus on generating dynamic content for your customers and have just all your assets in S3. And so some of the benefits you get out of this is, for example, let's say you have an application where users are uploading user-generated content. Now, all those assets are going into S3, and when your EC2 instances scale up and down, you never have to worry, oh, do I have all my assets on all my EC2 instances? And as you're generating a lot of content, that starts to add up. The other benefit you have is if you have multiple properties or multiple games, you can share those assets with all of those properties. And Matthew will actually talk about that a little bit more later. Third best practice is securing your origin. So as you know, we announced AWS WAF today, so you want to make sure that all your requests are being funneled through Amazon CloudFront. And so the way you can do that is you can use our origin access identity feature to protect your S3 origin so that only CloudFront or other authenticated requests can come through. For custom origins, you can create a IP whitelist. And we'll talk about how to do that, keep that up to date without any effort. So to go into this a little bit more detail, what we have here is a user trying to access our S3 bucket directly, and they're denied access. But if they access it through CloudFront and they're granted access through CloudFront, then they're able to access the static content from S3. Protecting your custom origin, same thing except for with IP whitelisting. And so you can see here users trying to access, for example, let's say my ELB directly, they're going to get denied. If I go through CloudFront, they're able to access the content. And so how do you keep your whitelist up to date? So as you know, AWS publishes all of our IP ranges in a JSON file that you can download and consume. And so, and it's broken down by service as well. And CloudFront is one of those services that's broken down. And so the ranges are broken down. And so what you can do is you can create a Lambda function that subscribes to an SNS topic that we publish to whenever the ranges are updated. You can get the IP addresses for the CloudFront service, and then call AWS authorize EC2, the EC2 API to authorize the security groups, and then make sure that you always have the latest up-to-date IP addresses authorized. And you don't have to ever worry about, am I keeping them up to date? It's all automated. Fourth best practice I wanted to talk about is logging request IDs. And so this is important if you want to be able to correlate requests made to your origin by Amazon CloudFront, as well as logging requests in your application when you make requests to CloudFront. So both on the front and the back end. And we find this very helpful when customers are reporting trouble with CloudFront, or why is CloudFront doing this behavior, but I didn't expect it. We can look up, even though it's not an error, we can find the event of the customer's request relatively easy. So definitely recommend generating your own request IDs as well in your own applications. You'll find it a lot easier to find specific requests, especially if you're generating a lot of logs. All right. The last item I want to talk about is sending HTTP response headers. And so the 4 headers I wanted to talk about is strict transport security. And so this header requires that you serve all your content over HTTPS for it to work correctly. And so what this does is it tells your browser only make requests over HTTPS. And so this helps prevent downgrade attacks on your site. So some things to keep in mind when you are implementing this header is the max age, as you can see, is how long the browser typically will cache that information for. So you typically want to start with something small to make sure that you don't break some functionality that you weren't aware that may break when you turn this on. So that's something to keep in mind. The other benefit of this header is, yep, perfect. So the second header I want to talk about is X-frames options. And so this is helpful to prevent your website from being rendered in iframes, and this is a common attack for cross-site scripting. Excuse me, I'm drawing a blank, sorry. The third option is XXS protection, and so this is a header that activates the cross-site scripting module in browsers, even though a user may have turned it off. The one other point I wanted to make about the strict transport security header is if you turn this on, sometimes when you go to a website and you get a security warning saying the certificate doesn't match, do you want to proceed? If you use this header, it disables that functionality. You cannot proceed. So that's something to keep in mind as well when you do turn that on, is a user will not be able to proceed if you generate a certificate maybe that's expired or is not valid for the domain that you're serving the content on. And the fourth header I wanted to talk about here is the cache control header. And so that tells CloudFront how long to cache objects for, as well as any intermediary proxies or your end user browsers. And Matthew will talk about that a little bit more detail later. Great, so I'm going to go ahead and show some demos. So let's see, switch. Perfect, so here you can see I have two windows side by side, just to explain what you're seeing. And at the very bottom of the window, you'll see that I'm generating the AWS availability zone that this instance is serving the content from. So you can see on the left, it's same page as the right, but it's a different EC2 instance. So what I'm going to do is I'm going to go ahead and terminate these instances in US East 1 accidentally. Great, so while those shut down, terminate, my ELB is going to evaluate that the instances are no longer healthy, and then mark them as unavailable. And I'll come back in a second. Oh, sorry. I'll come back in a second to demo that we failed over. The second thing I want to talk about is the Lambda function to update security groups. So you can see here I have a CloudFront security group in my VPC that has only two ranges two IP address ranges allowed for both port 443 and 480. So what I'm going to do is I'm going to manually invoke the Lambda function, and it should update. As you can see, I'm just going to go ahead and manually invoke it. It should update the security group with all the CloudFront ranges from the IP ranges.json file. So we got a 200, refresh, and now we have all these ranges. And that Lambda function is always triggered whenever an event comes in because the ranges have been updated. Perfect. The other thing I wanted to show you real quick is the origin access identity, and you can enable that in your origin. You just restrict bucket access, check it to yes, select your origin access identity. If you want us to automatically update your bucket policy, click yes, click yes. So let's go back to our demo and see if we failed over. Perfect. So you'll notice on the right, it says US East 1B. Sorry, on my left, US East 1B. On the right, US West 2C, it automatically failed over. And once the auto-scaling group heals, and we'll fail back. Great. We'll go ahead and switch this back. Perfect. So key takeaways. Definitely use Route 53 health checks and DNS failover, especially if you're using load balancer. You just have to check a box, evaluate target health, and configure your latency-based routing policy that you would like to use. Improve security by setting the custom headers at your origin. Enable logging of headers. Label logging of request IDs, specifically CloudFront, or generate your own request IDs as well to help find specific requests for your end users. Serve your stack assets out of Amazon S3, and definitely serve customer message out of Amazon S3 should none of your origins become unavailable, should I have accidentally terminated all my instances at the same time. With that, I'm going to go ahead and hand it over to Jared.
Thank you, Quinn. Hello, everyone. How many of you use CloudFront? How many of you are familiar with our reports and analytics that we've been releasing the last year? Wow, okay. Not many. So what I'm going to show today is how you can gain visibility into your distribution using some of the tools that we have native to CloudFront and using some other tools like CloudWatch and CloudTrail. Well, there are a variety of ways to get visibility into your distribution. We're going to cover 4 today. Using AWS CloudTrail for monitoring distribution configuration changes, using your real-time metrics provided by Amazon CloudFront via Amazon CloudWatch, using Amazon CloudFront Reports for analytics, and using Amazon CloudWatch logs for custom reporting. So CloudTrail is a service, as an AWS service, that tracks API activity across services, ELB, EC2, S3, CloudFront. It allows you to basically audit any API activity that occurs. In this case, you can set an alarm when there are configuration changes on your distribution, such as a distribution being disabled, trusted signers being disabled, or custom TLS certificate changes. We'll go into a little bit more on that in the demo. Another way to gain visibility into your distributions is using Amazon CloudFront near real-time metrics. This is via Amazon CloudWatch. Currently, you can alarm on 6 metrics, and I forgot to mention that these metrics are within 1 to 2 minutes of the actual activity that, maybe 2 to 3 minutes of the actual activity that occurred of the request for your content. Currently, you can alarm on 6 metrics. Includes requests, bytes downloaded, bytes uploaded. Those are usually come from post requests. 400 series error rates, 500 series error rates, and total error rates. An example of something you might alarm on for 400 series error rate, let's say that you've created new assets on your website or created a new version of your website. You see you've created an alarm on 400 series error rate, and you get notified, and you realize that you have a problem. A lot of those newly released assets are getting error rates, so it actually allows you to roll back, or you could roll back, make the decision to roll back. Same with the 500 series error rates. If you have errors to your distribution, you can get notified of those errors and then dig into what's occurring, either using logs or some of the other reports we're about to go into. Now, some of these reports that I'm about to show you are actually delayed a little bit. They're delayed by up to an hour. And we have released over, I think, close to 20 reports this year. So any of you that hasn't had the opportunity to look at them yet, we'll demo them, but you can also take a look at them today. Some of these reports include cache hit miss report, incomplete downloads, top countries, mobile users, popular objects report. We're actually going to go into those. I'm going to actually demo those and take you through those and show you how you can use them. Another way that you can get visibility into your distributions is through Amazon CloudFront Access Logs. Amazon CloudFront Access Logs you can subscribe to, and they can get delivered to your S3 bucket multiple times within an hour. So one really cool thing you can do with Amazon CloudFront Access Logs is generate custom metrics. And the way you do that is you can create a S3 notification, or actually via SNS, notify you every time you get log files delivered to your S3 bucket. And then that can trigger a Lambda function to take those files, download them, upload them to CloudWatch. And then you can create a variety of custom metrics, such as being notified, being notified of bots. If you get a large number of bots, you can create a custom metric on granular response codes, like 4XX. You can create, 400 series. You can also create a custom metric on certain URLs, TLS versions. So So we're going to go into a demo. So earlier we mentioned how you can get notified when there are configuration changes made to your CloudFront distribution. So we want to show you what this looks like. So this is via CloudWatch, and here's a CloudFront default log group. So we're going to show you what this looks like, how to set a CloudFront notification, or CloudTrail, a CloudWatch notification for CloudTrail. Sorry, I clicked on the wrong thing. So this is what it's like to set an event for that you can track via CloudTrail. Excuse me, this is a CloudWatch event. It's a CloudTrail group tracked via CloudWatch. So what you're doing here is you're tracking on a certain API activity. So for example, here you're setting event source is CloudFront. That's the service. The event source is CloudFront Amazon.aws. The request parameter is the distribution. And the request parameter distribution configuration enabled is false. Basically what this is a rule that's telling you that anytime your configuration is disabled, it's going to log a response or log a metric. So I go here, I log the metric, or I go in to see if anything's actually occurred. Let me see here. So I'm seeing that there was a disabled here and here. Well, that's not good. I didn't disable my distribution. So I need to set alarms so that I'm notified once the distribution is disabled. So you can create an alarm here that basically shows you, or tells you, that will tell you anytime it's disabled. For example, when CloudFront disabled is greater than or equal to 1 in this case, you're going to be wanting to be notified anytime this occurs. So greater than or equal to 1, you're creating for one consecutive period, because you just want to know anytime that CloudFront distribution is disabled, you need to create the alarm here. So this is basically setting a alarm on a CloudTrail activity. And again, CloudTrail is a service that tracks API activity or logs API activity. So it allows you to log on all these different events that occur in APIs, in the CloudFront APIs. So now I'm going to go and talk a little bit about CloudFront, some of the reports we've released this year. So you can see all these reports on the left nav here. These are all the reports, the cache statistics, the popular objects, the top referrers, and the usage reports are all reports that are available within about an hour of the event happening. The monitoring and alarming, these are available within 2 to 3 minutes. So I'm going to briefly go through these. I'm going to show you how these reports can be made actionable. So on the cache statistics reports, some interesting things here. So we have a total requests, percentage of viewer requests by result type that shows hits, misses, errors. Bytes transferred to viewers, that shows you basically how many bytes are being delivered. And then you have status codes, the type of status codes, 200 series, 300 series, 400, 500 series of the status codes that are being delivered as a result of the request. And then you have, this is an interesting report, we have the number of GET requests that didn't finish downloading. So this report is important because it shows you not only the objects that aren't, or excuse me, the number of requests that are coming for objects that aren't being finished downloading, but the problem here is that if a object isn't completely downloaded, it affects Amazon CloudFront's cacheability. So that in turn affects the latency of that object. Now in this case, I look at this report, how do I make this actionable? Okay, so I'm seeing these requests. So then I want to go into my popular objects. So I can use this report called popular objects, and I can try to correlate which objects might be causing the incomplete downloads. So if I go here, I see this object here. Oops, it's got 19, you guys see that? 19 incomplete downloads. and there's been 48 requests. So about 40% of the requests coming for that object aren't completely, are not downloaded completely. So all that means is someone might be downloading the video file and then leaving before it completely downloads. For example, let's say you have a training site and you're serving training videos. Some of your customers might not be staying until the end of the video, so they're exiting. That's resulting in a incomplete download. Now, what's actionable here is you can take that file, in this case is an MP4, and you can have it basically converted into a segmented format, so that you can do that via Elastic Transcoder, so that it's a smaller file set, so it's segmented. So if someone downloads it, they're getting a segment. That way, we'll cache it. And you see all the other files here. These are actually segmented, where this one isn't. So that's an example. And now a couple other examples I want to show that I mentioned. Viewers, I talked about locations. Here's a locations report. This shows you, again, this is a demo account, so it's not completely, it doesn't have that much activity, but this shows the top locations by country. And here, for example, you'll see Sweden. Let's say, in this case, wow, I'm getting a lot of people from Sweden. That's a surprise to me. I might want to vary my content so that Swedish customers get a more personalized experience. So you can configure it in a way that using the same URL, Amazon CloudFront can vary the content delivered to customers who come from that location. And then one last thing I want to show here, top devices. So there's also a device report we provide as well. And on this one, it's on this tab, sorry. So you can see the devices your customers are coming from. Now, what's actionable here, if a large percentage of your customers are coming via mobile, as in the case here, you're going to want to make sure that your site is optimized for mobile users. So that's something you'd want to do if you hadn't done it already. So the last item that I'm going to talk about here is using CloudWatch for custom metrics. So this is what I mentioned earlier about using Amazon CloudFront to Amazon CloudFront access logs. These are delivered to your CloudFront S3, or excuse me, to your Amazon S3 bucket, and then you can create an SNS notification to trigger a Lambda function to download those files and upload them to CloudWatch logs. And once they're up to CloudWatch logs, that's where you can create a variety of metrics on anything in the log files. And I'm going to show you what these log files look like. Oops, I messed up. Okay, so basically what these log files look like once they're in CloudWatch, each one of these represents a request. Each one of these line items is a request. So you can run create any kind of custom metric based on any item in the fields here. So this gives you a lot of flexibility, so you can alarm on any one of these. And I'm going to show you some of the ones we've alarmed on here. Remember to get back, how to get back. So here we've created a couple filters. One, this was a bot. We're tracking the number of bots that are coming, because let's say you want to be notified if you get a lot of bots, because there are some good bots and there's bad bots, and you want to be notified so you can look into what kind of bots these are. So this gives you the ability to do this. You can see how many bots are visiting daily, and you can also dig in and look at what kind of bots are, and you can block specific bots. And again, using our AWS Wealth service that we announced yesterday, there's a lot of functionality that you can use on that to block certain requests. Another one is SSL v3. One of the items here, so you can count the number of requests you're getting for SSL v3. Let's say you're using Amazon CloudFront's custom SSL feature, and you've enabled SSL v3, which means you're serving SSL v3. And then you're like, well, that's not exactly the most secure thing, so I want to turn that off. So you can actually monitor how many of your customers are visiting your site using SSL v3. So you can see what kind of impact you're going to have if you turn that off. So I'm going to go back to So key takeaways, enable AWS CloudTrail so you can track configuration changes so that if a distribution gets disabled, you're immediately notified and you can take corrective action. Monitor your Amazon CloudFront reports. That's where we talked about if you have a variety of incomplete if you get a bunch of incomplete downloads, you're going to want to investigate how you can resolve that. Create alarms, error rates, requests, whatever you think is important. For example, you might want to create an alarm on data transfer because you're sensitive, you're price sensitive or cost sensitive. So you can create alarms to trigger when you have over a certain amount of data transfer. Subscribe to Amazon CloudFront access logs. Again, you can do that just to get the value of digging into logs, or you can also use a Lambda function to push those logs to Amazon CloudWatch, where you really have a lot of freedom to run any kind of reports you want. So I'm going to turn it over to Matt Baldwin now, Senior Software Engineer.
Thank you, Jared. I'm Matthew Baldwin, a Senior Software Development Engineer on the CloudFront team. I'm going to talk to you today about some best practices on improving the cacheability of your content. So there are 4.5 best practices I want to talk to you about. The first one is versioning your website assets. Cache headers and cache control headers to instruct CloudFront, other intermediary caches, and browser caches on how long to keep your objects in cache for. We talk about shared distributions, forwarded values, and the half best practices, path prefixing validations. The idea being that if you followed the best practices that I've given you before that, we won't ever have to use our invalidation tool, but it's there if you do need it. So let's get started. Versioning website assets. This is simply include a version number in the URL every time you publish new versions of your assets. And this is useful. For example, Jared talked just now about monitoring the 4xx error rate after a new deployment. If you've versioned your assets and you've changed the URL to them when you've rolled out the new deployment, you see your 4xx error rate spike. You can roll back the content that's referencing those assets and know that the previous version of the assets are still in cache, either in the browser cache on the end user's end or in the CloudFront cache. And we see two different ways that customers typically do this. The first one, including some version key in the URL. Here we've included a simple version number, but you might want to obfuscate that. Maybe you make that the size of the file, so it's not guessable, so people can't try and guess what your asset URLs are. And the other way is to include the MD5 sum of the content as a query string parameter at the end of the URL. Most static asset or most file stores will ignore query strings when serving files, but you can include the query string in your cache key in CloudFront, giving you a different way, a different mechanism to version your assets. Our second best practice is to utilize cache control and expires headers to give you fine-grained control over how long you want your assets or your content to stay in cache before CloudFront or intermediary caches will revalidate them. So cache control is a very powerful header. We'll talk a little bit more about that in a moment. And expires is another header that also tells CloudFront and caches that this object expires at this point in time, and that's when you need to go and revalidate with the origin. CloudFront also offers a feature called minimum, maximum, and default TTL, which allow you to override these values as they're applied to the CloudFront cache. And this only affects the CloudFront cache. It does not affect the browser caches. It does not change any headers as they're served out the door. So cache control, as I mentioned, very powerful header, lots of different directives you can include in it. And depending on the type of content that you're caching when serving, you may want to set very specific settings. So for our CSS, our JavaScript, and our images, which we've versioned, we're confident that they're never going to change. We're going to set a 1-year expiry time. So our max age is a really big number, which is 1 year in seconds. And that's going to tell CloudFront and browser caches to try and cache that as long as possible. A different use case might be for your index page or a landing page. You might want to set a lower cache control header expiry time. Our example here is 30 seconds. It may be content that's refreshed fairly frequently, but you still want to leverage caching of that content so that users do get the benefit of the performance benefit of CloudFront. And in our example here, we've also included a no cache directive, which says no cache equals set cookie. And what this tells CloudFront to do, and other intermediary caches, is to strip the set cookie header on cache hits. And this is important for landing pages, login pages, index pages, and so on. If your application is generating a session cookie for every unique visitor, you don't want to leak that session across users, so you want to instruct the any caches to strip the set cookie header. And our third use case is for live streaming. With live streaming, you might create a cache behavior in CloudFront for your manifest file or M3U8 for our HLS live stream. And ideally, your origin will be returning a cache control public max age equals 2, so that the manifest is constantly being refreshed, which allows your users to follow your live stream. To protect against origins not sending that header, what you might want to do in your CloudFront distribution is to configure the minimum, maximum, and default TTL for that one cache behavior to be equal to 2 seconds. And what this does is gives you some confidence that CloudFront isn't going to cache effectively your dynamic manifest for too long. Worst case scenario, you don't return anything, and the out-of-the-box defaults for CloudFront apply, and CloudFront will cache that for 86,400 seconds or 1 day. And your users are going to see the first segment of your live stream and nothing else. So minimum, maximum, and default TTL is a useful feature to help you protect against that. The third best practice I'm going to talk to you about is shared distributions. And this is something that Colleen mentioned in his talk. And this is a use case where you may have several website properties. Perhaps you're running a CMS or a blogging platform where there's a common set of shared assets. It could be JavaScript, it could be CSS, it could be images. And what you might want to do is create a CloudFront distribution. Here we've got assets.example.com as the CloudFront distribution, serving all those static assets from S3. And we have two different website properties, example.com and example.org, which are pulling their shared assets from that shared distribution. This is beneficial to you because you are now going to get a better cache hit ratio. If users are switching between multiple of your website properties, assets may already be in their local browser cache. Good chance they're going to remain in the CloudFront edge location caches because now the popularity of your objects, which determines effectively how likely they are to stay in cache, is magnified by the number of different properties referencing them. And this is a technique that's used by the Amazon.com retail website and the regional variants of that. The Amazon logo is the same whether you're in the United States or Canada, for example. So Amazon.com uses a shared distribution to serve the images. The fourth best practice I'm going to talk about is forwarded values. CloudFront allows you to configure various different forwarded values for your different cache behaviors, which is a powerful way for you to deliver unique and personalizable content to users. But the effect is that these values are not only forwarded back to your origin, but they also form part of your CloudFront cache key. So if you're forwarding a lot of values, that's going to potentially impact the cache hit ratio. And last week, Trusted Advisor had launched 2 new checks, one of which integrates with CloudFront, and it scans your distribution configuration. It checks to see if you're forwarding values which have a great impact on the cache hit ratio, such as user agent, and it will actually make recommendations to you so you can be notified of changes you can make to improve the cache efficacy of CloudFront. And my half best practice, if we followed all our versioning and cache control and forwarded values best practices, we won't have to issue any invalidations. But you can use it as a last resort. It only applies to the CloudFront cache. You can't invalidate and purge things from end-user caches. And the easiest way to do this is to use the path prefix invalidations feature that we launched earlier this year, which allows you to use a wildcard at the end of a path and say everything that matches this path prefix invalidate it. And the next access to that will be a miss on the CloudFront edge location, and we'll go and pull the new version from your origin. Cool, so let's go to a demo, and I'll take you through some of the things we just talked about. Okay, so here we have the CloudFront console, and we have our distribution for our demonstration website. And you can see here we have multiple cache behaviors. Each cache behavior is doing a different thing. Let's take a look at the cookie cache behavior. And one of the things we've done here is we've whitelisted some cookies that we want to forward to the origin and make part of our CloudFront cache key. Any cookie that matches CloudFront-* and the JSession ID. Our web application is a Java application, and we want to make sure that the session ID for all of our users is forwarded to the origin on this cache behavior. If we switch back to our assets cache behavior, where all our static assets are coming from S3, we can scroll down here, and we see here we're not forwarding any cookies. They don't make any sense for our assets. So we're going to maximize the chance of cache hits at the edge by reducing the cache key space effectively. And here we go. Here are our assets, cookies. So we talked a little bit about the minimum, maximum, and default TTL earlier. So on this cache behavior, this is our live stream cache behavior. We've set our minimum TTL to 0. We set our maximum TTL to 300 and our default TTL to 60. And what that's going to do is the minimum TTL comes into effect when an origin may return a cache control header with a value that's less than the minimum configured in CloudFront, and CloudFront is going to clamp the age in the CloudFront cache. Let's take an example here. So we change this to 10, and origin returns cache control 5. CloudFront is going to apply a 10-second TTL. The maximum TTL works in the same way. It applies if the origin returns with a cache control 600, we're going to clamp it to 300 in the CloudFront edge location. And the default TTL comes into play when your origin doesn't provide any cache control or expires header and gives us no idea of how long you want to cache things for. So we have to make a decision, and we apply the default TTL in this case. And these values just apply to the CloudFront cache. We don't modify any headers as they're served out to the viewer. Cool, so the key takeaways, version your assets enables you to quickly roll forward and roll back. Use multiple cache behaviors, separate the forwarded values, and set appropriate minimum, maximum, and default TTLs. Forward only the required headers that make sense for the different parts of your web application. And ideally only use invalidations as a last resort. As I said, that only applies to the CloudFront cache. It does not apply to browser caches or other intermediary caches. Thank you very much. I'm going to hand over to Alex to take you through testing your configuration.
Cool. I'm going to go quickly through some best practices around basically how do you know all this stuff actually worked. So specifically, we're going to look at pseudo development mode that you can use to test your CloudFront configuration, how you ensure caching, how do you know that your stuff is going to be cached correctly, how do you performance test, how do you load test, and how do you validate your SSL settings. So those are the 5 things I'm going to walk through pretty quickly. So development mode. There's no switch to turn on development mode in CloudFront, but basically there are some things that you can do that allow you to validate that your CloudFront distribution is set up correctly without exposing your site to the whole world. So the first thing to do is to set the maximum TTL to 0. So that was this feature that Matthew just showed. This will basically ensure that CloudFront doesn't cache anything. That allows you to sort of experiment, work in your development environment without having CloudFront cache objects for a very long time. And without actually changing the headers on the objects, so that's very useful. Also without having to wait for invalidations to apply. The second is it also lets you not have to change forwarding headers. So you can do this all with the forward header behavior that you're going to use for your live site. You can also whitelist your IP address using AWS Wealth so that an application is only accessible via your internal network. And then finally, you can use signed cookies to use our private content feature, again, to further restrict access, so it's only valid for a certain period of time. One of the things that Jared showed you was looking at the ratio of hits and misses from a CloudFront cache. You can also see on an individual object whether an object is a cache hit or a cache miss by looking at the headers returned by CloudFront. So see this in the demos. 4 of the headers to look at in the developer console in Chrome or Firefox are the H header, the XCache header, the cache control headers, and the HSTS header that Colleen showed you earlier. So in the demo, we'll look at the developer console and see how you can see those headers. Performance testing. Performance testing is super hard. I'll just start with being honest with you that it's not easy to get an accurate perspective of what your end users see in terms of performance. You can get one view, which is your performance from your site, but how do you get an overall view of your performance? So when we started CloudFront, most customers use what are called backbone tests. These are tests that are run by third-party services that run in data centers and test CloudFront from those data centers. And they get a fairly good view of availability, but they don't do a great in terms of performance because you don't have a whole lot of end users that access your site from data centers. Your users don't live in data centers. They live in homes and they have ISPs, or they're in businesses that have ISPs that aren't represented by backbone tests. So the next generation of performance testing, what we've seen customers use is last mile testing. Last mile testing is still synthetic, so it's running a set test, downloading an object or testing a website using a pre-programmed script or other synthetic monitoring, but it's doing it from more consumer-grade ISPs. Again, good, but it can be incomplete. So the way we recommend as sort of for best practice to give a most complete view of performance and availability is real user testing. What real user testing does is it takes instrumentation from the same end users that are actually downloading content from your site. So basically, instruments your web pages and records information around availability and performance from the same people who are actually coming to your site. This is the gold standard for performance testing. There are actually several real user testing companies that are on the exhibit floor here at re:Invent, so I encourage you to check those out. Load testing. Load testing is another thing that is fairly tricky to do with a CDN. What traditional load testing tools do is they take a single IP address from a single client and they run it super hard. What that does is it circumvents a bunch of the load balancing that we've built into CloudFront, and it doesn't actually simulate a real user environment. So if you have, say, a load test script running from an EC2 instance that pulls down one CloudFront IP address, what that will do is test a single CloudFront edge location and a limited set of servers within that edge location, just the set of servers that happen to be behind that one IP address. An ideal load testing system tests from multiple client locations using independent DNS resolution. So that's the key thing. CloudFront uses DNS in order to accomplish a large portion of its load balancing. So an effective load test will simulate the DNS behavior that end users do, use different DNS resolvers to make independent DNS requests. That's the best practice. And then the last thing we will show you, there's a cool tool that's out there that will verify your SSL config. So it goes through this is a test from SSL Labs, goes through a series of tests on your SSL configuration and ensures that it hits the various marks that are important for securing your content while in transit. Let me very quickly just go through. I'm going to show you a couple of things. This is the developer console. And so this is a site that we put up at Edge re:Invent. And if you enable the developer console, I'm using Chrome here, but there's a similar version in Firefox. You can look at what we see here in the response headers. So here you see the age. You'll see the cache control directives that are set by your origin. And then here's that strict transfer security header that Colleen talked about. And so that is saying that, hey, we want to make sure that only content is available from over an SSL connection. And then lastly, sort of wrapping up very quickly, you can see here is Qualysys's SSL Labs report on aws-reinvent.com, and you can see that it goes through a variety of different tests, and in this case we got an A+, which is pretty cool. Come back, and oops. So key takeaways, switch off caching in development mode. That's going to make your testing much more productive, allow you to iterate more quickly. Second, use real user metrics for performance tests. That's going to get you an end user view of what performance and availability really look like. And finally, if you do a load test, do it from multiple locations. Do independent DNS lookups so you get a wide set of IP addresses. You don't just test a single set of servers in a single edge location. You really test CloudFront as a network. Thank you very much. I hope that you've taken some things away that are going to really help you configure CloudFront better. The group here will stay behind and answer any questions that you might have. But thank you for coming.